In this video, we're going to talk about using the speed, distance, and time relationship, and we're looking at the reading page in your packet, which I think is page 49. What we're looking at here is an equation that we're going to be using, which we've already been using. We're just going to talk about how to solve for different things in it. So we've got this equation right here. Speed is the change in position over the time taken, and we can write it with just letters like that. Sometimes when we write this equation, we write it like this, where we write speed equals distance over time is another way you would see it. Time like that, and then we could write V equals D over T. In fact, you may have even seen V equals D over T in math class. So a little bit about the different units that you can use and what you're doing. So the distance that you travel goes on top, and the time goes on the bottom. And the units that you end up for speed are simply whatever the distance unit is divided by the time unit. So we took miles and divided it by hours right there. Centimeters divided by seconds, millimeters per day, meters per second. Meters per second is our common one. But whatever the unit is of your distance and the unit of your time, that will be your speed unit there. So let's try an example here. And you'll want to copy along with me here. We've got Ari runs a distance of 20 kilometers in 3 hours at a constant speed. How fast does he travel? It says to draw a graph, but look at that. It's already there for us. Isn't that handy? And a motion diagram. So we'll do the motion diagram first. It says he's going 20 kilometers in 3 hours. Doesn't really matter what we're doing here, but he's going in the positive direction at a constant speed. So my arrows are the same length and my dots are evenly spaced. That shows a constant speed in the positive direction right there. So let's do our solution. So on your worksheet, you'll probably see like an XI and an XF and sometimes a time and a V for you to fill information out. And sometimes you can use that, and if you don't want to, you don't have to. The initial position would be 0 and the final position would be 20 kilometers because it says he travels 20 kilometers. And it says it takes 3 hours to do that, so we put 3 hours for the time, and then speed is what we're looking for, so I put a question mark there. And I'm going to write my equation here. V equals triangle x over triangle t. That triangle means change in, and now I'm just going to substitute my numbers in. So my change in position is from 0 to 20. That's a change of 20 kilometers, and my time is 3 hours. Right now you can see here's my distance divided by my time. That's going to be my speed unit. So I'm going to plug 20 divided by 3 into my calculator and I'm going to get 6.67 kilometers per hour. So there's my answer right there. So that wasn't too difficult. Let's try looking at the next example. This example is asking for a different piece of information. You can see here how far does it get. This time, instead of looking for the speed, what we're looking for is the change in position. So that's what we're going to do. So, we also have some interesting problems here. Okay, so in the solution it says we make calculations. It's a good idea to choose units that we'll use and stick by them. The example uses millimeters and seconds in the speed, in the definition of the speed, but it asks us how far it will go in 6 minutes. So we have to pick minutes or seconds to use. I gotta be honest, I think I'd rather use seconds. And 6 minutes, so let's see, there's 60 seconds. Whoops, that's the highlighter. There's 60 seconds in 1 minute, so I'm going to be multiplying 6 times 60, which gets me 360 seconds. So this is the time that I'm going to use, not that 6 minutes. Okay, so let's list this out. It says that my speed was 2 millimeters per second. And the time that we're going to be looking at is 360 seconds, and our distance is what we're looking for. Okay, so here's our formula that we're going to be using. This is going to take a little bit of math help here. So my formula works like a map. In this spot, let me highlight it instead. In this spot, I would put the V. Here I would put the triangle X, and here I would put the triangle T. So what I'm going to do is I'm going to set up my math just like that. There's a spot here where I'm going to put V, a spot here where I'm going to put triangle X, and a spot here where I'm going to put triangle T. So my V is 2 millimeters per second, and my distance is what I'm looking for. So people are pretty good at solving for X in math class, so I'm gonna use an X there, but you could put a triangle X if you'd prefer, or a D. And then the time is that 360 seconds. Now, a lot of people have an easier time solving these. It says down here that you can include units, but sometimes it's easier to do the math without the units in the way, especially if the units confuse you. So we might write this as 2 equals x over 360. Now, everything you learned in algebra works in physics also, so we're just going to solve this exactly the same way we would in algebra class. So I'm going to take both sides. I got to get that 360 away, so I'm going to multiply both sides by 360. That's going to cancel this. Let me change to a different color so we can see it. That's going to cancel this 360 out. Whoops, not that one. And so I'm going to be taking, on this side, I'm going to have x left. And then on the other side, I'm going to have to take whatever 2 times 360 is. Let's see, 2 times 360 would be 720 is my answer there. And now all I have to do is put my units on it. So I had millimeters in my speed up here where I wrote it. This right here, that's my distance unit, distance divided by time. So on this 720, I'm going to put millimeters. So that wasn't too bad. So there's my answer. Okay, everything you learned in math class works here too. Okay, so now example 3, we've got my dog Toto running at a speed of 15 kilometers per hour. She runs a distance of 325. Now they did this to us again where this meters is not the same as kilometers, so we've got to do a little bit, but this one's an easy one. This one, all you have to do is divide by 1,000 or move that decimal place over. So this will be 3.25 kilometers. Okay. So we need to figure out how long she'll take, draw a motion diagram, and draw an x versus t graph. Okay, so does it have, okay, it's got some places there for me to work with. Okay, so here's my givens. My triangle x is 3.25 kilometers. My triangle T is what I'm looking for, so I'm going to put a question mark there. And my V is that 15 kilometers per hour. So if I do a little bit of predicting, what unit will my time be in? Hours. All right, so we're running with a constant speed, so I'm going to use V equals triangle X over triangle T. And now I'm going to use that as my map for where I'm going to put those numbers. So I've got my equal sign and my line. I'll keep the purple. All right, above the line is where my triangle X goes. That's the 3.25, and I'm going to leave my units out of the way. My speed goes to the left of the equal sign, so the 15 goes right here, and then what I'm looking for is down here. Now, this is the most often missed thing in all of physics, well, at least for uniform motion. Students, for some reason, they don't know what to do first here, and it's difficult. So I'm going to make it red so it stands out. So the first thing you have to do is multiply by the x on the bottom. There's an x. We've got to get the x off the bottom. We can't divide by nothing. We can't just leave it there. Even Chuck Norris can't do that. So what that does is that makes me cancel out my x over here. And so when I rewrite this, I have 15x, which I'm going to write in red now. I have 15 times x, and that 3.25 over here. Now I can get x by itself, so we'll pick a new color. I'm going to divide both sides by 15 to get that x by itself. So I'll have x here, and then 3.25 divided by 15. I'm going to have to use a calculator to do that. Let me get my calculator up here. 3.25 divided by 15, and I get 0.21 and some other numbers, but I'll round off. And then I said that my unit would be an hour. We'll make that go away. All right, so it took less than an hour, in fact 0.21 of an hour. We could probably calculate just how many minutes that is, but we're not going to worry about that today. All right, so motion diagram. 15 kilometers per hour. I don't know if that's fast or slow, but it's moving at a nice constant speed. So I got to have two arrows at least that are the same length to show that it's a constant speed. And then I'm not going to worry about calculating the slope on my graph. I know my slope has to be 15 kilometers per hour. So what I'm going to do is I'm going to draw this, what do you call it, qualitatively. So it's going to be like that. It's a nice straight line. When we're moving at a constant speed, we have a nice straight line. So this is our position, and over here is our time, and we end up with a nice straight line for this position versus time graph. All right, now you can move on to the next page.